So what is garbage collection, right? What is garbage collection in Java basically, right? How do you create an object? What are the ways that we learned as of now to create an object? One way is using the new operator, right? New operator, what exactly it does? So object you created, what does it mean, object creating, and using the new word you can create an object? It means you are literally using certain memory and allocating it to the object that you want to create, and keep on modifying the values as and when the object get called, as and when the object get updated, right? So new operator basically used to allocate memory for the object along with all the instance variables, right? That sounds good, but is there any operator, or is there any keyword that is available so that you can clean up that memory, right? Using new keyword, like, whenever you say run the program, JVM will be loaded, and among the JVM certain piece will be gone for Java management, and certain two pieces it will be converted. One is heap and another one is stack. So stack is stores memory, methods and method reference variables, and local variables. Objects will be loaded here, right? So object will be loaded as and when you use the new keyword, and as and when you convert that, like, as and when you want to create an object and assign some variables inside, then object will be created. Object is creating in sense certain memory is getting occupied. In this section of memories, each object is going to occupy its own memory, right? 8 bytes, 8 bytes, I mean not 8 bytes, or whatever the memory size that we allocated, whatever the number of variables inside, number of methods inside, type of variables we are using, all this matters, the size of the object, right? That is good. So you utilize this object, you operated that object, and you played with that object, and you executed your program, and you moved on to something else, right? So is there any operator that Java provides us to clean up this memory? No, Java doesn't provide you any operator to clean up the memory. Then how come this memory is going to be deallocate? Otherwise, what happens like this? If you keep creating, what happens? This memory is completely occupied. So if you want to create another object, you cannot create. Then out of memory exception, out of memory error will be displayed. Out of memory error will be displayed, right? Every time. Let's say, what I'm trying to say is, let's say you have 500 MB of heap memory you allocated for your to run the program. And if you keep creating an object of size, let's say 10 MB, how many objects you can create maximum? 50 objects, right? Once it reaches 50 objects, so 50 into 10, each one takes 10 MB, so 500 MB is used. So if you try to create 51 object, then you don't find a memory. Then Java says, hey, whatever the memory that I gave for the running your application, it's overflowed, and so I couldn't create another object, so I'm throwing you an error, and I'm coming out from the program. You go and fix it, right? So something need to be there. That is where Java will take care. Instead of giving control to the user, Java will take care in cleaning up the memory. So it need to be very cautious, right? Java simply cannot clean up the memory. So you created these many objects, okay, and you are still using 1 and 2, okay. These X, Y, Z, P, Q, R, these 6 objects you already utilized and you are done with them. But these two are you are still utilizing, you are running some programs on these two, right? If Java simply goes and clean it up all this memory because some new object is trying to come, then your running program will break, right? So it has to follow some rules so that It should honor whatever you are doing, and it should be smart enough to detect these XYZ PQR and then clean them up and create the new object here, keeping the utilizing objects as is, right? So what rules it follows, right? What rules it follows? Before say that, before we get into that, so garbage collector is something JVM will use it to clean up the memory, to clean up the heap memory. So garbage collector is a service thread, right? We haven't discussed about threads, but it's one kind of a thread that is always running in your program. Let's say you are operating these objects with your running your application parallelly. Some a thread will be running here. Keep on checking, is there any ones that are eligible for cleaning up? Is there anyone that are I found it, let clean it up and free up the memory. So this is a daemon thread. Garbage collector is a daemon thread running behind the scenes and clears the memory. Okay, who creates this thread? JVM creates this thread when your application started. Okay, when your application started, JVM creates this thread. Okay, so what are the criterias to remove these objects? What are the criterias that it follows to remove the objects? Okay, first and foremost is, let's say in your memory, okay, simple rules it follows, but very yet powerful. Let's say obj reference variable holding x, y, z object having blah 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 variables inside. Okay, so the address will be 1110. This address, this obj is holding the object some xyz, right? So now as it is holding this object, Java doesn't touch. Even though you are utilizing or you doesn't utilize, it doesn't care. As long as you are referring it, as long as you are referring by reference with as long as this object is referenced by any reference variable, then it doesn't clean up this object. When it cleans up this object, only when obj 1 equal to null. When you say this line, then this one will be disconnected. Agreed? This one will be disconnected because now instead of 1110 you are keeping explicitly null, which means this obj1 no more knows xyz object, which means this connection is disconnected, right? With this line, that is what are going to happen. Then this object is nobody referred, so this is eligible for garbage collection. Okay, when you assign a null to any reference variables, then the object which is referenced by that reference variable earlier will become eligible for garbage collection, which means it's clean it up. Okay, that is rule number one. What is the rule number one? When you assign a null to any reference variable, then object which is referenced by that reference variable is eligible for garbage collection. So let's see, I'll show it to you here. So what it is saying is, mm, okay. So this toddler is having private string name, private int age, okay, some void okay, public void public void plain int. Okay, so toddler, I'm going to create a, whatever the spelling, okay, pardon, toddler td equal to new toddler, yeah, toddler. Okay, so now td is having, this is the reference variable and it is holding toddler object. The toddler object is with name Rutvik and age 20. He is having two methods, and this one, this td will be in a stack and this object will be in heap. So whether this object is eligible for garbage collection? No, because this toddler object has been referred by td reference variable. You see what I'm saying? So when it becomes eligible, when this object you created, the created object becomes eligible, td assigned to null. Now you disconnected this connection until this line, until executing the, before this line, you know, the highlighted, until here, as new toddler object has been held by td, then new toddler object that has been created, toddler object that has been created is not eligible for garbage collection. As and when this line reaches, as you are updating this td variable from object to null. So this one is getting updated from the address that is holding of this object new toddler to become null. So then this object will become eligible for garbage collection. So that is the number one case. When you assign a reference variable, to null, then that object becomes, then the object holding by that reference variable becomes eligible for GC. Make sense? That is case 1. So what is the next case? Now you have object 1. So it is holding an object which is having some blah blah blah, and it is holding this object, let's say XYZ. Then you have another object obj2 PQR object, or let's say, not to for the sake of justification, we'll say another XYZ object. You can create as many XYZ objects as you can from XYZ class, right? So I created another XYZ object and assigned it to obj2. Now XYZ XYZ object here, XYZ object here, both are not eligible for GC, right? So when I say obj1 equal to obj2, not double equal to, I am assigning obj2 whatever the variable into v obj1. So let's say this one is having earlier 1 to 1, this one is having 1 1 1. Now I am assigning 1 1 1 to obj1 as well. So I am assigning 1 1 1 to obj1. So this one will be erased. This becomes 1 1 1, which means this connection will be established. This connection has been established, and this connection has been disconnected, right? So then this object will become eligible for garbage collection, rule number 2. Okay, so what I'm trying to say here is, let's say second scenario, toddler TD1 equal to new toddler TD1, another object, okay, toddler TD2 equal to new toddler. So now up to this line, this object and this object both are not eligible for GC, right? So when they become eligible for DC, so when I say TD1 equal to TD2 or whatever the one, so now you assigning TD2 object to TD1, then what happens? This object becomes eligible for garbage collection. So in this scenario, object hold by TD1 before assigning TD2 object, before assigning TD2 will become eligible for GC. Agreed? Any confusion? What if I say like this, right? TD2 equal to TD1. What happens? Then TD2, this object becomes eligible for garbage collection because you are assigning whatever the address that TD1 is holding to TD2. The address that TD1 is holding is new toddler of the first object. So this object becomes eligible for garbage collection. But to satisfy above statement, I am keeping it here. Otherwise, I need to change that. So what is the third scenario? Last scenario. So when you assign one object to another object, then unreferred object will become eligible for garbage collection. Okay. When a reference variable, third one is when reference variable reaches out of scope, then that object becomes eligible for garbage collection. Let's say toddler td3 equal to new toddler. Okay, then td3 so let's say here I'll say, okay, and just little bit creative, okay, just give you more clarity. I'm creating here again, okay. Now I'm going to call this guy. Why I kept static here? Because I want to call it in static method. Static method, there are only two ways to call. One is if you want directly call, then you need to make this method as static. Otherwise you need to create garbage collection demo object and then call this method, right? So I felt this is easy. So imagine now we know when certain variables here and here objects becomes eligible. Now third scenario is when reference variable reaches out of scope, then that object becomes eligible for garbage collection. When reference variable reaches out of scope, it's a common sense actually. Then that object, becomes eligible for garbage collection. Okay, so what happens is now your program starts running here, and when you look at this method, it will go to that method and it will start running this method here, and it creates the object, and if you do some operations around that object, it will take that object. Once you're done here, it will go back to here, then it will start running this program, continue the program. So the scope of this td3 is up to here. The td3 object reference object, the object that is the object that has been held by td3 scope is up to here. As and when it comes out, then this becomes eligible for garbage collection, because nobody can't access it, right? Nobody can't access it. Make sense? As and when you went out of the scope of any particular object, then that object becomes eligible for garbage collection. That is the scenario 3. Okay, how does it runs? Like how does, okay, now we understand what are the eligible rules. That is good, but who invokes this? As we know, like JVM invokes, but is there any way that you can do, that a developer can do to enforce garbage collector to trigger it? Nope. All you can do is you can request it. You cannot enforce. All you can do is you can request, saying that, hey, if possible, run garbage collector on this line after completing this code or after reaching here. If possible, can you do this for me? That's it. If it works for JVM, if it works for JVM to run that, it will run it. Otherwise, it doesn't run it. So it doesn't guarantee. JVM doesn't guarantee for any of these calls. You can explicitly ask to run the GC. How you need to ask is like, system.gc. This is system is one of the Java built-in class. dot gc. This is one way to call. Okay, and another way to call is runtime dot get runtime dot gc. Actual runtime dot gc will give you what you call the runtime object, and then you're going to call the gc. So these are the two ways you can ask JVM when you are running your program to execute garbage collector if possible. Okay, we cannot force the GC garbage collector to run. Okay, so one important point we need to remember is, let's say you are running program and let me show you with the diagram, you can easily understand. Let's say you have 500 MB kind of memory for objects, and you created an object and you are going out of memory and talking to Excel file, XLS, whatever the Excel file. Okay, you created another object, you talking to database. Database is outside JVM, right? Next you talking to PDF. Next you talking to Word doc. Like you talking to outside system with all these objects that you are creating outside the JVM systems, like to read from XML file, to update a Word document, or to parse PDF file, to update database. You're doing with something with the objects. So the JVM got filled out. Now it's try to come and try to clean up. It finds so many objects, and sometimes it couldn't able to, garbage collector now cannot able to clean it up because each one is doing something, right? If let's say if two objects are talking here between each other, and if the memory has been filled, then garbage collector comes and it will kills them. Okay, because you filled the memory, I have to do something, so these are the ones I can clean it up. I cleaned up, you can create another object. What if this one also goes to talk to the database? Next, if you try, somebody try to create an object, everybody is talking to the outside the JVM, outside the world, then no object is getting released because your Word document got hanged, or PDB got hanged, or your GC, the XML, XLS got hanged because of n number of reasons. Your objects are not getting released even though your program is completed. Then garbage collector cannot do anything until you fix this program. Okay, until you fix this program, garbage collector cannot do anything. So sometimes some objects may refuse GC to reclaim the memory because these objects are holding some other resources like network connections. These are all network, when the connection goes out of JVM, these are all called network connections. Okay, so what we need to do? First we need to release these resources. First we need to release these connections explicitly. Okay, by making your program more sophisticated. Okay, so as a programmer, it's yours and my responsibility to write the cleanup code, because you know which object you are using, because you know which objects you are using. Okay, so where do you need to write this cleanup code? Where do you need to write the cleanup code? Because if you want to invoke GC before GC running, whenever GC want to clean up some memory, what it does, there is lot of objects has been created, and GC keep on looking here, and as and when it find it want to run the GC before cleaning it up. Okay, let's say these two are outside and you done with the outside network, IO operations are doing. Okay, these two objects, and GC is running, and you done with these objects, but this connection is still established and it's not releasing. So first what it says is you write this cleanup code to disconnect this IO network somewhere, so that I will run that logic first and then I will start running cleanup code. So here when you write this, where do you write that logic is that finalize method. There is a method called finalize. Okay, when you write some logic inside, you need to write such a logic where you need to clean up the code before garbage collector get called, so that by running this finalize method, you whatever the logic that you written will be used to release these connections, and then these objects will be cleaned by garbage collector. Okay, so what happens is, in order to run JVM, in order to GC to be called, JVM first invokes the finalize method, then whatever, based on the logic whatever you wrote written, all the resources connections will be released, and then JVM invokes, triggers this GC, go and trigger now and clean up the memory, so which starts clearing the unused object by following the 3 rules. Okay, I'll show you simple example so that you can, like I said, it doesn't guarantee, right? So but we'll give it a try. GC request demo. Spent 1 hour on this, not good. I'll create some object, class GC ready. Okay, this is my simple object, and now what I'm going to do here is GC ready object. Anyway, I need to create an object, right? Ready object equal to anything, you can name it. I just take GC ready object. Okay, and then ready dot method 1, ready dot method 2. Okay, so now when I run this program, no harm, right? There is no much logic, just it will run the program. What happened? Please don't do this again. What's happening with the system? Every time when we try to run the program, it is screwing it up. Come on, something wrong. Okay, so now if you run this program, hey what's up, and two methods get called, right? So let's say I will say, like, protected, either is a whatever the method that they referred, right? Protected void finalize. This is the method you need to override from object class, from real object class. Okay, okay, this is the finalize method they've referred you to call, and here you need to have a logic to release all your connections, all network connections, like database, XLS, PDF reading, all the bluff connections to release all the network connections that you established as part of your program. Okay, let's say you are writing that logic here. Okay, network connection logic. Let's assume this is the network connection logic. Okay, so you want to first release, then only you can request GC to call. So just to prove that, I'm going to write here some garbage if it triggers, then garbage, whenever garbage collector want to run, first what it does is it looks for, is there any finalize method available? If the finalize method is available, it will trigger this, and then it will run the garbage collection. It will trigger this, and then it runs the garbage collection. So as I'm saying, it triggers this when it indirectly, I am saying if this method is getting called, then I can say garbage collector is called. Okay, garbage collection thread triggered to clean up memory. Okay, so but you can request GC, right? There is one way to request GC is system.gc. Okay, let me run. Well, what happens? This one get called? Nope. You requested, but it didn't get called because it kind of felt like there is no garbage collection objects. There is no point in running it. So let's try to make, I'll make a ready equal to null. That is one of the criteria, right? Let's see what happens. Nope, not get called. How do I prove? Sometimes it will get called. If I create this main class object, will it create? All I'm trying to say is, before, when you request this line, right, when it reaches this line, it looks for there is an object ready for eligible, and you requested GC, before calling GC, what JVM does, it's try to execute whatever the logic that you have here, and then it calls this. So that is where I'm trying to prove it. Let me try another way. I'll create an object of this class and see what happens. GC demo equal to, I'm just trying different ways to see if I can trigger. Okay, so yeah, there are different reasons, right? Like, like I mentioned, it can, you need to convey that there is an object that is ready for our garbage collection. Okay, so let's say if I keep it this line here and see, will it cause? No. And if I say this guy here, call. So before calling GC, as you are explicitly making this garbage collector request for this garbage collector demo, and you created that object, and then you made that object immediately null. So GC demo becomes null. So when you call, so now and you're explicitly requesting call, if garbage collector, if possible, please run the GC. So as it decided to run, so when it decided to run, what will happen? First JVM runs the finalize method. So it runs this finalize method. That is the reason you see this method. And then it will trigger whatever the garbage collection objects are there. Make sense? Yeah. That's it about for today. Tomorrow